The purpose of this lesson is to explain the meaning of the term derivative, or as it's often called, dy dx. So to get started, I've drawn a curve here, and so this is the function y equals f of x in blue. And let's pick some random point on the function, the point a here, and the coordinates of a are x, fx, so that means it's x across on the x-axis and it's a height of fx on the y-axis. Now, I want you to also consider a second point b up here, and to get at b, have a look down here first. So from 0 to here is a distance of x, because that's the point x, fx. So from here to here is a distance of x, and from here to here, let's go an extra distance h along here, which means we're now at x plus h along the x-axis. Now, if that's a distance x plus h along the x-axis from here to here, well then if we come up here, that means that the x-coordinate is x plus h. And if that's x plus h, the x-coordinate, well, the y-coordinate is the f of that. It's the f of x plus h. And of course, fx plus h is now the height across here on the y-axis. Now, the next thing to consider is this line here in red. This line that cuts the graph in 2 points is called a secant. And if you move this around here, you can see the secant. And what we're going to do next is we're going to get the slope of that secant. And the slope is the rise over the run. So I have it worked out over here, rise over run. Now to work out this, you can see that the rise here, well, that maps onto the difference in heights between fx plus h and fx over here. So for example, right now it's on 10 and 2. So the difference between there and there is 8. So that corresponds to a rise of 8. But in general, the rise is just fx plus h minus fx. So there's your rise there. And the run, of course, is just simply h, because don't forget we just moved on an extra distance h here, which corresponds to the run on the diagram. So slope of secant m, rise over run, is the difference in heights, fx plus h minus fx over h, which is the extra length we moved along here as well. Now, the next thing we're going to do is move this point b closer to x. Now, as it's getting closer, you can see the secant is getting less obvious. It's actually turning into a special line called a tangent. So the tangent is the line that cuts the curve at just one point. And you can imagine what's going to happen eventually if I bring this point B down on top of A. They're now the same point, basically. So there's only one point of intersection between the line and the graph, and that's the tangent. And we're now going to try and get the slope of that tangent. Of course, there's now a problem because we no longer have a rise over a run. To get a rise over a run or a slope, you need 2 points. Just by looking at the diagram there, you have to have 2 points to work it out. So how do we get around that problem? Well, what we do is we have to imagine that we bring this point as close as possible. And you look at h down here as well at the same time. H is getting smaller. As the points get closer, h gets smaller. H is actually approaching 0. But let's go as close as possible without being 0. Because as I say, when it's 0, we can't measure the slope. So you have to imagine that point where it's as close as possible without actually being 0, without h being 0. And there's a name for that in maths. It's called limit. It's the limit as h goes towards 0. So what we do over here is we have to imagine the slope of the secant, rise over run here, and then imagine h becoming as small as possible until it's virtually 0. Well, then it's no longer a secant. It's now the slope of the tangent at that point. And that's what dy dx means. So dy dx has all this meaning packed into it. It's a very simple term, but it means an awful lot. There's 4 parts to it, really. So dy dx means slope of tangent to the curve at the point x, fx. So as I said, an awful lot of meaning crammed into that one little term there, dy dx. And there it is once more. It's the rise over the run. But the rise over the run, the slope worked out as h goes towards 0, because that's the one that gives you the slope of the tangent. And that's the end of the lesson on the derivative.